This is AP Calculus Lesson 2-2. We're on Standard F. Again, Standard F, we're still doing basic derivatives. So let's learn about finding u. There you are. Haha. No, okay. Okay, so finding u really is talking about finding the inner. So if you can add it up here if you want, but it's trying to find the inner of a function. So let's talk about the different types of houses. So I'm always going to be referring to these as houses. If you go to college and you refer to them as houses, people look at you like you're crazy. This is just something that I do to kind of help us remember what house we're in. So these are the different outer types, and then we'll find the inner once we know what house, what outer we're in. So these are the forms of these houses. The general house will look like this. A times some function, and then parentheses, this is where the inner lives. Another way that you can do this, you can have a different type of function, right? So you could have a times g of something. This is where the inner is. The inner is inside the parentheses. And that's going to be true for almost, I think, all of these. Yeah, all of these. All right, so we know what the general house looks like. It's some function time, and you can have like a might be 1. Assume that a isn't 0, otherwise it's trivial, right? So the trig house, what does the trig house look like? Trig house looks like a times sine or cosine. So let's just say a times sine of whatever. Whatever's inside the parentheses, I'm always going to call the inside parentheses inner. Another one, let's do cosine or tan or something like that. A times cosine of the inner. So far, so good. Like everything's on that bottom line, inside the parentheses, that's the inner. It's really easy to find what house we're in. Obviously, sine and cosine trig house. Let's talk about E house. It's a little bit different, but also similar. So A times E to the power of inner. Anything in the exponent when I'm in E house is the inner. E house. Okay, let's talk about log house. Building log cabin here. So I have A. I always do an A because you might have a number out front and that doesn't affect what house you're in. A times something like natural log of the inner. Side note, in AP Calculus AB, you'll only have natural logarithms as far as I can tell in terms of having to calculate them. Once you hit BC, then you need to know logarithms. And that comes with change of base form, which Rochelle has just been reviewing in pre-calculus and stuff like that. And then finally, powerhouse. So this is going to be A times something to the power of something. So I could put a box up here. Let's just put an N. Some number, some power. And then, of course, the inner is inside the parentheses. So we were dealing with, in the last lesson, powerhouse. Because we had something like x squared. The x would have been the inner, the squared would have been n, a would have been 1. We were dealing with powerhouse yesterday over and over and over again. You guys are really good at powerhouse by now, I hope. All right, so let's continue on. Let's look at a bunch of examples. I want to, like in today's lesson, all I care about is just identifying the house, identifying what house you're in, identifying the outer, identifying the inner. If you can identify those things, then you're set up for the next lesson. So I'm going to title this Identifying the Outer. And again, these are words that I use that aren't strictly AP Calculus, the outer and the inner. All right, so let's look at our first example. Example 1. So I have this function, 3x plus 1 to the power of 7. Okay, what house am I in? I'm in powerhouse. What's the inner? X plus 1. And what's the outer? And this one I'm going to do because I have a very specific format that I want. The format that I want is everything with the parentheses. So I'm going to go like this. 3, oh, there's the inner. Don't touch the inner to the power of 7. That's how I like to format the outer. All right. So technically, whatever goes in here, I can label that with a U. So I can leave it blank or I can put a U. For the sake of the notes, I'm going to put, so this thing is our U right there. So this U goes in there. And something that is pretty important to note is that the derivative of U, and I'm going to write this out here on the side notes, dx, the derivative of U, in this case is what? What is the derivative of x plus 1? 1, exactly. That is important to note for all of these. You'll be able to find all of them and then take the derivative as well. Maybe I should have just included that. I mean, there's 4 things you always have to find. That's one of them, so I guess I should have written that down here. We'll do that for example 2. We'll have the correct form. Example 2. So let's do this function. 1/2 natural log of 2x. Okay, first, house. Then what's the inner? Then what's the outer? And then what is dx? What is the derivative with respect to x of u? All right, so Arrow, what house are we in? Log house, yep. Ben, what's the inner? 2x. 2x, so I'm going to say u is equal to 2x. Be a little bit more formal about it. And the outer is what, either one of you?
1/2 natural log.
1/2 natural log of that thing. Perfect. And what is d dx of u, the derivative with respect to x of u, Arrow? So I'm just looking at u. Remember, u right here is equal to 2x. So what is the derivative of 2x? This is from yesterday's powerhouse. This is x to the power of 1. So 1 comes down in front, 2 times 1. So it's 2 because, okay, let me go through this process. So this is 2x to the power of 1. 1 comes down in front and gets multiplied by 2, so it's 2. And then subtract 1. X to the power of 0 is, yeah, exactly. Perfect. We'll get rid of that. And let's do an example 3 off to the side. You can do it below if you want in your notes. I don't really care. I just want to squeeze it onto one slide. Let's look at this function. E to the power of 2x. I want to know what house we're in. I want to know the inner. I want to know the outer. And I want to know what the derivative with respect to x of u is. All right, do them independently right now. Check up on the board to see if you're doing it correctly. Thumbs up, thumbs down. Did you get all 4? Cool, let's go on to the next slide. All right, let's talk about inners. I guess that would be your subconscious if I'm continuing on with the metaphor. So your inner. All right, so let's look at this function. I'm going to do this in blue because it's not really an example. So let's look at e to the power of natural log of, in parentheses, 3x minus 1 in parentheses. Let's assume I was doing the same thing as I was for the last problem. So I want to be doing the house. Then I want to do outer, then inner. And instead of doing the derivative with respect to x of U, I'm going to hold off on that. All right, so what house does it seem like we're in?
Isn't it both E and log?
Yeah, E and log house. E first and then log house second. I guess, well, depending on what order of operations, but I saw the E first and then log house. But yeah. So what is the outer here? What is the most outside function? The thing you'll do last if you're calculating something that you're plugging in with x. Yeah, so it's e to whatever. The inner here is u is equal to whatever goes inside of the outer. Inner always goes in the outer. I mean, that it makes sense. That's why I labeled them like this. U is equal to the natural log of 3x minus 1. But because if I were to take the derivative d dx, don't write this down. If I were to take the derivative of u, I would find that I can't solve this. And at least not yet. You will be able to solve it in a sec. Well, not in a sec, in like a month or so, in a sec. But we can't do anything because there's another house that we have to deal with. When there's another house, you have an inner. Your inner, the inside of the inside is, we'll call it V. V is equal to, so I guess if we identify the house, the outer of this would be natural log of whatever. What's on the inside of the house? If I'm in log house right now. Inside of log house is?
3x minus 1.
There it is, 3x minus 1. Now if we take the derivative with respect to x of V, I should just get a number. I'm just trying to end with a number. This derivative is what? Shout it out. 3. Perfect. So you might have some inners on your homework. I don't know if they are labeled. I can check the homework right now. Yeah, so I tell you whether or not you're going to have an inner. You just need to find out what that inner is. Any questions on identifying this stuff? This is the first block in being able to take the derivative of all of these different houses. That's where we're going with this. I'm going to just start randomly giving you these houses. But yeah, I just want to identify these parts and know that it's in that house. All right, that concludes this lesson.